So good afternoon, everyone. So it's a real pleasure to be participating in this online symposium. The title of my talk today is Techniques of Design Democratization. I will look at the kind of technical substrates of design democratization from a more historical and critical perspective. So this topic has occupied a substantial part of my scholarship, which examines how specific mathematical and algorithmic techniques have been taken on by architects and the kinds of theoretical, political, or other agendas that these techniques have supported in the last few decades. I also wanted to say that you can find a more expanded version of this talk in the form of a book chapter that's coming out in a couple of weeks in the context of an exhibition catalog published by the Architecture Museum in Munich by Teresa van Hennel and Andres Lepik. So this talk today is kind of like part of a more expanded chapter that I've written for this exhibition. So again, I apologize for being short of breath. I think I'll get my breath kind of like back in a second. Okay, so let's jump right into it. So in his 1980 futurological compendium, The Third Wave, Alvin Toffler forecasted the return to a pre-industrial condition in which the divide between the consumer and the producer would collapse, giving rise to a new persona that Toffler called the prosumer. Signals of the prosumer's rise, he argued, were distinct yet converging tendencies, from self-help movements and do-it-yourself trends to computer-aided manufacturing technologies that turn products outside in by involving consumers in their design and production. The so-called prosumer encapsulated a vision of creative consumers with direct access to and control of their technological environments. The image of empowered individuals shaping tools and products in collaborative communities, what Lewis Mumford had famously described as the condition of democratic techniques, has been from the onset central to emancipatory claims associated with the so-called participatory web. Also called Web 2.0, the term describes the World Wide Web shift from an information source to an interactive infrastructure dynamically populated by user-generated content. Apart from being interactive and participatory itself, Web 2.0 is also indirectly promoting prosumption, creative consumption, through online product customization interfaces, and crucially by igniting speculation on alternative so-called open processes of design and production. So as Nicholas Carr writes, personal empowerment is the central theme of an almost universally accepted liberation mythology associated with information technologies. The central hero of this mythology is the figure of the empowered user, portrayed as the prosumer, as I just described, or differently as the designer user, innovation user, producer, or maker, to name a few of the variations. So these neologisms allude to a technologically mediated transfiguration of the user from a passive consumer of technologies, products, information, and environments to an empowered individual with active participation in their shaping. In his 2011 blog article, Digital Style, architectural historian Mario Carpo echoed this vision when he implored theorists and designers to head-on tackle what he identified as the digital's most radical effect, what he called an aggregatory mode of authorship and production that relied on versioning, patching, reconfiguring through what Carpo called the hands of the many. This architecture, he argued, would be the product of processes similar to those in place in open source software development. Recasting drawings and buildings as binary code would open them to the kind of creative individualism that he saw as being present in Web 2.0. Even though professional architects may not have taken on Carpo's call en masse, the housing industry has veered in this direction with organizations such as WikiHow, and various digital so-called configurator tools marketing a digitally enabled self-design and self-build. These tools rely on kit-of-part logics of discreteness, modularity, and combination to make designing architecture as simple as choosing from a menu. This is their claim. In broad brush strokes, configurators are digital interfaces that prompt users to choose from menus of pre-designed components, which users, and I use the term users because, I mean, we can debate that a lot, but it's kind of like a keyword that's being used in the context of user-centered design and human-centric design. So users choose from menus of pre-designed components, which they then combine or customize to define the final form of a product. Users combine kit of parts, each carrying specific information, specific data, and the digital platform constrains which combinations are permissible or what their implications are in terms of various criteria, such as costs, performance, etc. And although these configurators are inscribed within perhaps a narrower spectrum of mass customization, a configurational logic in which the designer provides an infrastructure that is then made concrete through the assembly of parts or the provision of certain variables is the standard way of thinking about the participatory, interactional, democratizing potential of the digital in design and architecture. So this, lots of text, but this is a bit kind of the thesis of today's talk. So today my talk aims to offer some historical episodes that reveal a bit more clearly a particular model of open-endedness that is embedded in digital tools for self-design in architecture. So I will suggest that the very idea of digitally powered participatory architecture can be inscribed within a historically specific imagination of design that stemmed from architects' engagement with particular cultures of abstraction in the post-war period. And this imagination is an enumerative imagination, an imagination of configuring and counting different types of possibilities and different types of configurations. So I argue that the shift from authoring the appearance of things to authoring their configuration is not an unrealized potential of the digital, as many argue today. It's kind of like one of these persistent agendas that seem to have remained kind of unfulfilled. But that this agenda was in fact one of the key agendas that underpinned architects' early engagements with computers and computation. In other words, that configuration is something that we really need to think about when we're thinking of relationships of architecture and the digital. I also argue that this agenda can be understood as a simple shift from appearance to structure, or to give this idea a visual and kind of technical handle from designing geometric shapes to configuring their graphs. And graphs is a technical term that I'll be talking a lot about today. It's the little kind of skeletal entities that you see on the screen here. Graphs are mathematical entities that consist of points that represent abstract objects. In the case of this image, you see kind of abstract configurations of 3 rooms. So every little square is a room and is shown as a point. And then the relationship of adjacency and connectivity between rooms are shown as lines. So basically graphs are mathematical objects that became very popular in the 1960s. They were sort of undervalued by mathematicians earlier, but in the 1960s, in the context of several shifts that were happening in mathematics as well, that started valuing structural understandings of things as opposed to geometrical or numerical understandings of things, graphs really gained prevalence. So today I'll be talking a little bit about how these entities ignited sort of like a particular participatory imagination of design in the 1960s. So graph-based representations of floor plans became quite prevalent in a key area of research in early computer-aided architectural design, or CAD. And this area was known as space allocation or automatic spatial synthesis. So space allocation occupied a large portion of early work on CAD and drew from methods that were initially developed in building science. So building scientists in the United States and the UK had developed computer programs as early as the 1960s that, given a repetitive pattern of activities in space, configured rooms or equipment so as to minimize the time spent walking between the points in space in which these activities were performed. In other words, if you knew statistically how people would move in a particular building type, the idea was that you would be able to translate these patterns of activity into spatial patterns using graphs. And some of the representations that you see on the screen are from this early work on mapping people's movement and using graphs to translate it into kind of optimal floor plans. And I have a paper that's just out with one of my colleagues, David Theodora, in the Annals of the History of Computing journal that's kind of like looking a little bit at this history of mapping activities and automating floor plans in the context of post-war hospital design in the UK. So these programs, with early notable examples being the Craft system by Armour and Boffa in the United States, or Whitehead and Eldarcy's, you see it on the bottom, single-story building layout system, computed optimal or suboptimal layouts for a given pattern of human activities. And in the beginning, they were really inscribed within functionalist values of economy and efficiency. So the idea was that you could really build a kind of like cheaper building, a building in which kind of the costs of operating it, the costs of people working in it would be kind of minimized. So all of these programs relied on a topological abstraction of the building as a set of departure and arrival points. In other words, they started representing the floor plan as a graph, like really the geometry of the building didn't really matter. It was all about kind of like understanding points in space and their relationships. Methods that explicitly used graph theory to solve the space allocation problem, which is the problem that I've been describing, how you allocate space kind of optimally for a given pattern of activities, through just pencil and paper, circulated also in architectural literature since the early 1960s. So in other words, you didn't necessarily need to use a computer. You could use these kind of graph-based techniques and just draw them out with pencil and paper and kind of compute these kind of like optimal spatial layouts. So an important representation that grew out of this work was the so-called dual graph, which allowed to move directly from a graph that showed the connections between rooms, what you see on your left side, the kind of rhombus is the adjacency graph that basically like shows rooms and their connections. And if you put like a point in the middle of each area that's defined by the graph, you then have the floor plan. So there was kind of like an idea that you can, without distortion, move between this representation of connectivities to a kind of representation of the layout of the building itself through this kind of idea of the dual graph. So this representation would ultimately become the foundation of an entire field that was called Configurational Studies, or otherwise architectural morphology, that was pursued very vigorously in the UK and the US from 1965 to 1975. So one of the groups that championed this research was the Center for Configurational Studies at the Open University in Milton Keynes in the UK, that was founded by the former director of a really influential group at the University of Cambridge, known as the Land Use Built Form Studies Center, which pioneered some of the kind of like earlier applications of mathematics and computing in architecture. So the focus of the Center of Configurational Studies was the development of what they called a science of architectural form through mathematical research on how you can produce exhaustive catalogs of possible building configurations. So in other words, how can you count every single floor plan that you can produce for a given number of rooms, and how you can then sort of like evaluate all these different configurations depending on certain criteria that you have sort of like set out for yourself. So a central idea in these studies was what they called the dimensionless representation of architectural plans. So what they did, which I think rings very familiar for people who are familiar with parametric design today, was that they separated the metric or dimensional properties of a floor plan or of a form more broadly from what they call the configurational properties. So in other words, you know, there was kind of like the structure of a space, and then dimensions was something that was kind of calculated on top of it. Like these were seen as sort of like separate. So in floor plans, the dimensionless shape was achieved by abstracting the floor plan as rectangles packed within rectangular boundaries. So you see, again, these are very abstract schematic representations, but in a way that speaks to the spirit of the work that was being done at the time. So here on the left of the screen, you see the outline of a building shown as a rectangle, and then the rooms are just shown as kind of dissections of that rectangle into smaller rectangles. So dimensions were removed by creating an unequally spaced grid that was called a grating, by using each rectangle line on the X and Y axis and then applying a transformation to make all grating cells equal. So in other words, dimensions were removed and all that remained was the kind of dissection of the bigger kind of like rectangle into the smaller stuff. From this representation, one could directly derive a topological diagram, a graph that represented the adjacency and connectivity of rooms, and also use techniques from graph theory to begin counting possible plans. So this is one of these kind of counting exercises. The problem of enumerating possible rectangular packings within a rectangular boundary came to be known as rectangular dissections. That was a mathematical problem that really occupied certain research groups in architecture around the early 70s. Who tried to either sort of like solve it through pencil and paper, and a lot of them tried to automate it. So a lot of the early algorithms that were developed in computer-aided architectural design were about like really taking the boundary of a building and then figuring out all the possible ways in which it can be sort of cut out into smaller rooms. So I guess what I want you to keep from here is this kind of intense interest in the idea of an exhaustive enumeration, like a counting of possibilities, so as to produce like really a kind of menu that contains every possible floor plan you could imagine for like a certain number of rooms. So this is something that really kind of captured the architect's imagination, the idea that with these mathematical representations, you would be able to like really know from the onset, like what your options are when you're designing something, as opposed to kind of designing it through intuition or kind of prior experience. Like the idea was that you could like really map what today we would call kind of like an entire design space, like all possibilities for a given kind of like problem. So graphs, my argument is the techniques, the little kind of skeletal entities that were used to enable this counting of floor plans became a symbol of a particular model of possibility. Possibility understood as an operation of kind of combining discrete entities, of like really figuring out all the counting all the possible combinations and configurations between kind of like a discrete number of things, in this case rooms, in the context of spatial layouts. The end of the 60s found some of these techniques being repurposed under different architectural agendas. This shift coincided with social and political events that challenged scientific expertise as the source of decision-making legitimacy and brought user participation in architecture and planning at the epicenter of design debates. So here you see the cover of the 1971 Design Participation Conference of the Design Research Society, which was an important organization that brought together early work on computer-aided design, but also design methods. And in a way, this was an organization that in previous years was more kind of concerned with scientific and rational approaches to design. And in the turn of the 70s, this conference in a way signaled a change of attitude in the organization that really kind of foregrounded the participation of people in design as a potential remedy to what some of the presenters described as the harmful side effects of design professionals' decisions that were at the time proving incapable to predict and eliminate the undesired consequences of their projects. So the idea was a little bit that there was a kind of professionalism that was suffering. You know, the idea was that professional architects were not able to predict the unintended consequences of their designs. And the idea was that the people who would bear the consequences of design decisions should be the ones that are making those decisions. So that was kind of like the moral ethical claim. So among the conference presentations in this particular event were provocative papers that were imagining how computers could be used to promote a kind of like do-it-yourself architecture without the mediation of any design professionals. So in other words, non-expert users just interacting with a machine and producing their own kind of designs. So among these papers was French-Hungarian architect Jona Friedman's paper, Information Processes for Participatory Design. So for those of you who are not familiar with Jona Friedman, he was a really important figure in the so-called kind of like radical architecture of the 60s. You might have come across his Ville Spatiale, which was a kind of mega grid infrastructure in which he was imagining people doing and undoing their own kind of dwellings at like following their own kind of social and personal processes. So he was really kind of like one of the vocal advocates of a kind of techno-utopian kind of participatory design sort of approach in Europe. But he also like flirted in the late 60s, early 70s with how technologies such as computing could be sort of like integrated in his imaginations of mobile architecture and do-it-yourself design. So this paper that I'm talking about that was presented at the Design Participation Conference captured the key points of a book that Friedman published the same year in 1971 that was called Pour une architecture scientifique. Then it was published in English as Towards a Scientific Architecture. And it's interesting that in this book, Friedman developed a process, like a design method based on graph theory. I mean, you can see the little graphs like all over the screen, which he described as a method for democratizing design. So like a really kind of like a method for producing what he called a remodeled architectural process in which a designer would not be making decisions on behalf of people in what Friedman called a kind of paternalistic manner, but would present the future users of a space with what Friedman said would be all physically possible configurational choices of floor plans for a given number of rooms. So what the architect would do would be that they would be presenting the future user with the menus that we saw earlier in some of the earlier work that I showed, like really all physically possible choices for a floor plan layout. And he imagined accompanying those with an objective evaluation metric that had to do with the efficiency of each floor plan based on a person's daily habits. So it's really interesting because the idea was like, these are the little numbers that you see here. that a person would be kind of carrying a little keyboard with them, and every time they would enter a room in their house, they would press a button. So it's kind of a self-tracking exercise for figuring out like how you use your space. And then this data would be used to understand how the different floor plans that are possible given a design brief would in a way be efficient or kind of align with a person's kind of like daily habits. So Friedman never cited space allocation work like everything that I showed earlier. And it's very hard to ignore the affinities of this method with this earlier, more techno-rational work that I was kind of like showing. So his method really repurposed floor plan enumeration and layout efficiency calculations from technocracy to democracy, from techno-rational pragmatism to a rhetoric of user agency and empowerment. So he took methods that were used to kind of minimize cost, compute optima, and started kind of projecting those methods or like reframing those methods as really tools for design empowerment. Friedman recast the combinatorial generation of layouts as a register of open-ended possibility. So his method was, he was arguing, was kind of like a really open-ended method that really just gave you like all your possible options, right? So more crucially, however, and despite his iconoclastic statements, because a lot of his work was about how graphs are very mathematical, you know, that we're not relying on pictures anymore, that can be deceiving for people, that we rely on these kind of objective representations. He strongly advocated for the graph's intuitiveness and accessibility. Like there was kind of an idea that it is a mathematical method, but because you can sort of draw it with pencil and paper, it's not hidden behind the machine, you know, you can, that it's transparent for non-experts, you know, that anyone can understand these like little diagrams of space and can kind of think with them. So around 1975, Friedman's theory was incarnated in a computer system for architecture by yourself by the Computing Research Facility of MIT's Architecture Department, which was called the Architecture Machine Group. Some of you might know of it. Through a collaboration that started soon after the Design Participation Conference, which also featured a paper from the Architecture Machine, Friedman's methods materialized into an interactive computer graphics program that was called Yona, Your Own Native Architect, but also Friedman's first name, in which an unpracticed designer, that's what they called them, could topologically manipulate connections between rooms in a floor plan and then receive layout recommendations from a computer. So in other words, you would just draw the graph on the screen and then the computer would sort of like spit out all and compute like a menu of like possible configurations that, of possible floor plans for kind of the corresponding building that you've been sort of designing. So the Yona system brought the graph on the computer screen. The graph was presented as a kind of sketch, a malleable visual entity, accessible well outside the cycles of a mathematical elite. The representation of the graph as a sketch highlights values of intuition and congeniality attached to it, which had been recognized by design researchers such as Friedman. So by featuring the graph on the screen, the Yona system revealed its internal mathematical representation to its users. This revealing of the computer's interior to the eye did not only abide to Friedman's moral mandate of transparency, but also implicitly declared the graph as an interface between humans and machines, as an entity that spoke the language of both. It was something that was both kind of intuitively perceptible by humans, but also spoke a kind of abstract mathematical language of computing machines. An abstract mathematical object with tangibly concrete depictions, the graph cultivated optimism that human engagement with computers and logical mathematical methods needed not be seen in terms of dehumanizing quantification or mechanizing systematization. And yet, the graph afforded a particular conception of user participation that was, in fact, I argue, in close alignment with techno-rational understandings of choice and possibility. In theories of participatory architectural design, the graph was promoted as an objective substructure defining the extent of permissible choices and therefore supporting kind of superimpositions of subjective meanings or aesthetic choices. So in other words, once you had the kind of like layout of the floor plan, like you could start kind of embellishing it with like various shapes, putting kind of like arcs and crevices and like all kinds of things. But the idea was that the kind of objective spatial structure was kind of calculated in like a sure, certain kind of way. By subjugating choice and possibility under an abstract invariant structure, graphs tamed it under the certainty of a universe of combinations in which all possibilities of design are known from the start, before the user even kind of does anything, like the user just chooses from kind of pre-calculated possibilities. So, and I conclude, in 1996, writing on virtual worlds, media theorist Lev Manovich identified what he called a shift from creation to selection as a constitutive condition of their aesthetics, of the aesthetics of virtual worlds. The modern subject, he wrote, proceeds through life by selecting from numerous menus and catalogs of items. Manovich argued that this shift in subjectivity, what Alvin Toffler, the prosumer that I talked about in the beginning, had technically termed the configurative me or the modular me, also carried implications for creativity. So Manovich wrote, the great text of culture from which the artist created his own unique tissue of quotations was bubbling and shimmering somewhere below the consciousness. Now, he warned, this was becoming externalized and therefore greatly reduced through digital menus that were driving the creative process. So there's a story to be told about the democratizing potential of the digital for architecture, a potential that stems precisely from a quality of being digital, in other words, being a kit of discrete parts that are combinable and recombinable based on logics of multiple individuals or their collectivities. And yet there's a vexing sense in which configurative approaches to design, piecing together fixed digital or physical parts, promote a rather limited understanding of open-endedness, limited precisely because they assume all design possibilities to be countable, enumerable, before any action really takes place. We may then begin to contemplate limits of aggregatory, combinatorial, modular imaginations of participation, arguing that they do not necessarily democratize the architecture or the design, but confine possibilities within a very particular structural abstraction of architecture or design, its kind of organization or its skeletal diagram. We may also then start speculating alternative imaginations of democratization that embrace perspectives, positionalities, and ways of seeing, as opposed to relying on operations of combining physical or digital parts. So in other words, there might be a participation that has to do with a kind of like multiplicity of viewpoints without like really relying necessarily on the actual kind of reconfiguration of physical artifacts. How to retheorize participation and its relationship to architectural computation is a question for another time. I've clearly run over, but maybe we can discuss it in the panel after. But even to begin asking that question, we need to be aware of the historical and technical specificity of democratizations and participation's complicated relationship to design as a digital, discrete, and blocks-like process. So that's my presentation. Thank you.